Yeah. Yeah, good evening all. So in the last session, just I was briefing you about what is big data, why Hadoop, drawbacks with current databases, Hadoop and Spark advantages, Hadoop and Spark job market, right? Yes. So Hadoop is meant for two things, storage and for processing. For storage, we have got HDFS. For processing, may have to use Spark. Yes. Current databases, they're used for OLTP, online transactional processing, Oracle, MySQL, SQL Server, right? Specialized databases like Teradata, Netezza, Vertica, DWH, OLAP, right? Yes. Hadoop is for Hadoop is for batch applications. Hadoop is for batch applications, right? Two types of applications: online applications and batch applications. User interactive applications, we say it as online applications like booking a movie ticket, making an online transaction. Batch application, user non-interactive application. Here is user is no way required. Here user is no way required. User non-interactive, batch application. User interactive application, online application. Here user gives the input. Here user is no way required. Credit card statement generation for millions of customers. Mobile statement generation for millions of customers. Drawbacks with current databases, right? Limited storage, no parallel processing. As volume increases, speed decreases, right? Excuse me. As volume increases, speed decreases. Select total amount from sales 1, total amount from sales 2, total amount from sales 3. Sales 1, sales 2, and sales 3. Total amount from sales 1, total amount from sales 2, and total amount from sales 3. 10 records, 1 lakh records, 1 crore records. Record to record, as data increasing, speed decreasing, right? So the first query executes faster, the total amount of 10 records as compared with the other things, right? So volume increasing, speed decreases. Complexity increases, speed decreases. I want total amount of sales 1, average amount from sales 1, standard deviation of amount from sales 1. So query to query, as the complexity increasing, speed decreasing, right? As the complexity increasing, average amount is a two-step process. Standard deviation is more internal processing required as compared with the second one, right? Yes. Okay. Databases, one more biggest drawback of databases is can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Okay, Hadoop cluster, right? Group of CPUs connected in a network. Group of CPUs. Group of CPUs connected in a network, right? Group of CPUs connected in a network. Yes. So group of nodes are CPUs connected in network. Yes, there are two types of nodes. Yes, Anshu Rathod, any query? Yes. There are two types of nodes, master node and slave node. Master node responsibilities, task assignment, load balancing, fault tolerance, health monitoring, right? Hadoop follows master slave architecture. Hadoop follows master and slave architecture. Yes. Single master and multiple slaves. Slave 1, slave 2 up to slave n, right? Yes. Okay. F1.txt is divided into smaller parts. In Hadoop, data is stored in the form of files. So data is stored in the form of files, right? This f1.txt, it is divided into smaller parts. Each part stored in one slave, each part stored in one slave, each part stored in one slave, and are processed parallelly. So distributed storage and parallel processing, both we are able to see here, right? So if you come to this Hadoop advantages, so here master node assigns tasks to the slaves T1, T2, T3. Slave nodes executes the tasks. If any task is failed, then the task of that slave is assigned to any of the other slaves that we called as fault tolerance. Master node responsibilities. Master nodes assigns tasks to the slaves. Slave nodes executes the tasks. If any slave goes down, then the task of it is assigned to any of the other slaves. Unlimited data storage. Unlimited data storage is possible in Hadoop because of horizontally unlimited scalability. Because of horizontally unlimited scalability. Very high speed processing because of parallel processing. Very high speed processing because of parallel processing. Can handle all varieties of data. Hadoop can handle all varieties of data, structured, unstructured, and semi-structured. It's an open source, no licensing required. Hadoop is an open source, no licensing required. Commodity hardware like high configured systems are not required, right? With Hadoop can run on any configuration. So mainly unlimited data storage is possible. Very high speed processing is available, right? So why databases like Oracle cannot support unlimited storage? Databases like Oracle, right, or MySQL, they can handle up to some extent. Means max limit on the number of slaves for Oracle 256. For MySQL 54 nodes max. MySQL Express 256 nodes. SQL Server 256. DB2 256 max limit on the number of slaves, right? There is a limit on the number of the slaves. Beyond that, they cannot handle, right? Teradata has got 512. Netezza has got 512. Vertica also has got 512, right? Currently, they are supporting. Okay, 1 second. Give me a second. Yeah. So databases, there is a limit on the number of slaves up to 256, but Teradata, Netija, they can go with 1024 slave nodes. Still, we cannot say unlimited data storage, even they are using 1024 slaves, right? Yes. So here there is no limitation in Hadoop, but there is no limitation the number of nodes that Hadoop can have, right? Unlimited, horizontally unlimited scalability, horizontally unlimited scalability. When Yahoo first time implemented Hadoop, it went with 4,000 slaves. When Yahoo first time implemented Hadoop, it went with 4,000 slaves, right? Yes. Currently, Yahoo going with 12,000 slaves for storing its data. Facebook, when first time implemented Hadoop, went with 8,000 slaves for storing its data. Currently, it is going with 42,000 slaves for storing its data. So Hadoop is proven in the market storage point of view with unlimited number of nodes allowed, horizontally unlimited scalability. And processing point of view, right? A test was done. Yahoo has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. So time taken by, okay, Oracle, right? Yes, has taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. And Netija has taken 3 hours. And Hadoop has taken just 3.4 minutes. It has taken 3.5 days, Oracle. MySQL 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours. But Hadoop in minutes, 3.4 minutes. Latest watch, that is what the speed of Hadoop as compared with other things. Means parallel processing, because of parallel processing, right? So the data is distributed across multiple slaves and processed by multiple slaves parallelly. Hadoop ecosystem components. HDFS for storage, MapReduce for processing, Apache Pig is also meant for processing. We use a language called Pig Latin. Apache Hive used for data warehouse purpose, right? It's a kind of data warehouse kind of environment in a Hadoop framework. We use a language called HQL. We use a language called HQL, which is similar to SQL, which is similar to SQL. Scoop SQL plus Hadoop. The first two characters of this and last three characters for import or export operations, and for NoSQL database random access schemaless behavior, right? One of the NoSQL databases like HBase. We are going to see one of the NoSQL database, HBase. Yarn, yet another resource negotiator, right? From Hadoop 2 version onwards, we got many architectural changes. So how this yarn processing is going to happen, everything we'll be discussing, right? Zookeeper controls and coordinates all the Hadoop components. Eon, and Zookeeper. Flume Kafka for advanced streaming and advanced streaming and messaging, right? Yes. Yes, Flume Kafka, advanced streaming and messaging. Spark. First, I'll be discussing about SCALA, Spark Core, Spark SQL, and Spark Streaming. So here we see a concept of data frames here. Here we see the concept of RTDs. Here DS streams, micro batching, right? How exactly data stored in Hadoop? How exactly? How exactly data stored and processed in Hadoop, right? How exactly data stored and processed in Hadoop? In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file again subdivided. Each file is again subdivided into blocks. Each file is again subdivided into blocks. So Spark is a processing, very high speed processing. It is also meant for processing, right? So very high speed processing, in memory computation, data stored within the RAM and data processed in the RAM, right? Generally data stores in disk, right? But here in Spark, data within the RAM and processed within the RAM. That's why very high speed, and Spark has got high boom, right? Today in today's market, right? Okay. In Hadoop, data is stored in the form of files. Each file is again subdivided into blocks. Default block size. Default block size 64 MB. Default block size is what? 64 MB. Default block size 64 MB. But in the latest versions, right? Yes. Default block size 128 MB. 128 MB. Previously it was 64. Now current in the latest versions, default block size is 128 MB. Yes, default block size is 128 MB. Just observe this, right? f1.txt 200 MB. The file size is 200 MB. Think this is what? Banking data. So file size by default block size. Number of blocks equal to file size by default block size. 200 by 64, assume. B1, B2, B3, B4. B1, B2, B3, B4. 64, 64, 64. Means 192 plus area only 8 MB. Only 8 MB here. 8 MB stored in this. 56 MB free. 56 MB free here in this. 64, 64, 8 MB. Yes. 56. Now I got f2.txt. Telecom data. 192 MB. Assume that it's 192 MB. Number of blocks. Three blocks. B5, B6, B7. B5, B6, B7. So here why B5? So here my query is here 56 MB free. 56 MB is free in this B4. Why B5 data is not stored in B4? Why B5 data is not stored in B4 even the 56 MB is free? Assume if B5 data stored in B4. Assume if B5 data stored in B4, right? See, 1 second. In each file is subdivided into blocks. The file size is okay. A file of some or whatever size it is divided into blocks. Divided into blocks. 64 MB, 64 MB, 64 MB blocks. If the file size is 640 MB, 10 blocks required. 10 blocks required. 10 blocks into 64, 640. B5, B6, B7. Okay, so for example, retrieving b1.txt, I want to retrieve b1.txt, f1.txt, sorry. Think this f2.txt is a telecom data, the f1.txt is a banking data. Retrieving f1.txt, retrieving f1.txt means retrieving f1.txt, yes, means b1 plus b2 plus b3 plus b4. If b5 stored in if b5 stored in b4, 64 plus 64 plus 64 plus 8 plus 56, 256 MB. But actual file size is but the actual file size is 200 MB. So 56 MB, but the actual file size 2, but you are 256 MB, right? 56 MB of telecom data is retrieved. So understood, right? So every file is going to have dedicated number of blocks. Here actual file size is 200 MB. Yes. But you got 56 MB of telecom data is retrieved. Okay. So design principles with respect to HDFS blocks, right? Design principles with respect to HDFS blocks. Every file should have dedicated number of blocks. Every file, right? Every file should have dedicated number of blocks.
If a file size is less than 64 MB,
yes, we can also configure our own block size also. So by default it will be 128 or 64. Even we can keep our own block size also. Yes. In a single block, no two files are stored. No two files are stored. In a single block, no two files are stored. Every file should have dedicated number of blocks. No two files are stored. All the blocks will have equal volume. All the blocks will have equal volume except the last block. All the blocks will have equal volume except the last block, right? Every file should have dedicated number of blocks. In a single block, no two files are stored. All the blocks will have equal volume except the last block. Except the last block. We can also configure. Right? We can also configure the block size and replication. We can also configure the block size. For that, go to Hadoop installed folder. Go to Hadoop installed folder like the Hadoop. Within that etc folder will be there. Within that conf folder, within that hdfs -site.xml file, go to Hadoop installed folder, Hadoop etc conf hdfs -site.xml. Open this XML file and configure the following. Open this XML file and configure the following. XML file means our own tags. Configuration and here /configuration. Within that property, what property I need to set? Property and /property. Within the property name, dfs.blocks.size. I want 50 MB. Instead of 64 MB, I want 50 MB slash value, right? Okay. Now observe this, right? How exactly data stored and processing happens in Hadoop? Assume f1.txt size is 192 MB. Assume 192 MB. Number of blocks 3 blocks B1, B2, B3. B1 think that 10 lakh records, B2 10 lakh records, B3 10 lakh. Master and slave. We have got master and slave architecture, right? Single master and multiple slave, right? Slave 1, slave 2, and slave 3. B1 stored here, B2 stored here, and B3 stored here. F1.txt into how many, right? B1, B2, and B3. B1 in slave 1, B2 in slave 2, and B3 in slave 3. B1 in slave 1, B2 in slave 2, and B3 in slave 3. B1, B2, B3. B1 10 lakh records, B2 also 10 lakh records, B3 also 10 lakh records. How this data processing is going to happen? Data processing. Job is to process f1.txt, right? Job is divided into tasks. In Hadoop, always the job divided into tasks. Number of tasks always depends on number of unique blocks. Number of unique blocks. How many unique blocks here? 3 unique blocks right here. 3. So 3 tasks, T1, T2, T3. Job is to process f1.txt, right? Into 3 tasks, T1, T2, and T3. T1 for executing B1. For executing B2. T3 for executing B3. Who should execute this T1 task? That is to execute B1. Slave 1 only, right? No other checks. T2 by S2 and T3 by S3. All these 3 slaves, these 3 slaves executes. 3 tasks T1, T2, T3 parallelly. These 3 slaves S1, S2, S3 are executing 3 tasks T1, T2, T3. None of the task is in the waiting state. So full parallelism you can see, high speed you can achieve, right? So data divided into blocks, the blocks distributed across slaves, and the processing job is divided into tasks. Task depends on number of unique blocks, right? Slave 1, slave 2, slave 3. So 3 slaves executing 3 tasks parallelly. Understood, right? Any query in this? What we are discussing in today's session, everyone?
Suppose if any dependency for task 2 or dependence of task 1, once the task 1 completed, then that output will be due to task 2. In that case, error will not occur.
Yes, in such case, yes. If T1 output is given to T2, T2 output is given to T3, right?
Yes.
In such This it cannot happen. But here generally our records, a number of records, 10 lakh, 10 lakh, 10 lakh. We are providing some business logic. The business logic is going to be applied on each and every 10 lakh, 10 lakh, 10 lakh records, right? Parallel execution. Yes. Any other queries, right? Anyone? Okay.
Hello, sir.
Yes, yes.
Myself, Ashok. So
Yes.
I need that. What are the projects you will be discussing? List.
Projects won't be discussed. Only one project means one flow will be discussed at the end.
Which one? It's a batch processing or real-time processing?
So in Hadoop or Spark, we'll perform only batch processing only, no online processing. Right? Yes. Some project related to telecom I'll be discussing. Yes.
What is that? That is also.
Telecom related project I'll be discussing, right?
Can you tell me the details of the project?
No. We'll be discussing, I said, right?
Okay. Okay, sir.
Fine. Any other queries, right? Anyone? So I'm stopping here for now. So tomorrow there.
Sir,
Yes, yes. Go ahead.
Spark also, that is a streaming process, right? Not exact batch application, right?
Spark, it can perform Spark core programming, SQL, and Spark streaming is there. Micro batching is there.
That means it's near to online application, right? Online, not batch application, not also batch application.
Yes, sir. Spark is also a batch application. Spark is also a batch, right? No, it's a totally Spark is also going to run on Hadoop yarn only, right?
Okay.
It's going to run on Hadoop yarn because it's a master slave architecture, not request response architecture. Not like client server. We are not going to follow any client server. Request response is not followed. Master slave only followed, right? In us Spark also. But only thing is in Hadoop data stores in disk, in Spark data stores in RAM memory level. That's why high speed you see in Spark.
But online and streaming both are different, right? I thought streaming is another class. That both are different, right?
Streaming means live streaming,
Uh-huh.
live streaming data, capturing that streaming data.
Okay, okay.
The data you are going to capture it and going to store in Hadoop.
Okay, that's I thought.
And later by using Spark, we'll process it.
Mm-hmm.
You're using Flume Kafka. You are just going to capture the streaming data and store in Hadoop, and using Spark, we'll process it.
Okay.
Based on some business logic, right? Yes.
Yeah.
Okay, fine. So I'm stopping here for now. So tomorrow, that is Saturday, there is no session. Again, we'll meet on Monday, same time at 5 p.m. right, to see more on this. Right? I'm stopping here for now. Meet you on Monday, right? Yes. You can follow the same time, same link, right, to see this more on this Hadoop.